Hi folks, the purposes of this walkthrough are to show you how to get started on the Javagram assignment, how to get the starter code, and also to do just a brief walkthrough to show you what's in place there and kind of briefly describe some of the tasks that you will be completing as part of this assignment. So in order to get started here, we need to first get the most recent version of the code from the LaunchCode repository. So you've already set up the LaunchCode remote in GitHub, or in Git rather, to point at the LaunchCode repository in GitHub. And so now we just need to do the work to pull the most recent version of code down from GitHub. So go to Team, Remote, and Fetch From. So what we're doing here is we're basically telling Eclipse and its GitHub plugin, or its Git plugin, I should say, to fetch the most recent information from the LaunchCode upstream repository. So this won't actually merge any code or anything like that. It'll just go kind of query that remote repository for a list of recent changes. So in this dialog, make sure that you select the non-origin repository, whichever one you set up that points to the LaunchCode education repository. Here we've called it LaunchCode. So select that one and then hit finish. It's going to do some work, and here we go. So you'll see a list of commits here. You might have some more than I have here, but you will see a list of commits that have been made in the LaunchCode repository that are not reflected in your local repository. So we'll just hit OK. So now we have the most recent information. We are able to merge in those changes that we just got information about from GitHub by going to Team, Merge. Okay, and then in this dialog, make sure we select that we want to merge in the master branch of the LaunchCode repository. So just select that line under remote tracking and merge. And you should see some clean merge results here, no merge conflicts. All the code that's being pulled down are brand new files that, you'll be working with for this assignment. Okay, great. So now we have the starter code for this project. Let me just show you where it is. So you've got kind of two things that are of interest here. We have in the assignments folder, we have a couple of new packages. So packages are ways of organizing Java code into logical groups, and that also affects permissions and things like that. So so far you've probably just been creating stuff in the default package like I have here with student and course and that stuff. But for Javagram, we've started using packages, and so we'll talk a little bit more about these in class as we go on through the skill track. But just know that these are essentially just logical organizations of our code. They also correspond to actual folders that are on our file system. So if you go to, say, let's see, I need to go to the right directory here. And I'll just show you that when I'm in this directory, assignments, that I have a Javagram folder, just like I have a Javagram package. And within that, I have Javagram and Picture. Those are the two classes within the package, the same way that I have those two classes in Eclipse. And then within Javagram filters, this dot filters, the dot signifies that it's a sub-package of the Javagram package. And on the file system, that corresponds to a subfolder. So filters is a subfolder of the Javagram folder, and it has one file in it, bluefilter.java, just like it shows in Eclipse. All right. So what's here, and what is the program going to do? So this is basically a simple version of an image filtering program. So I'm going to go ahead and just run it for you. Javagram is the class that has a nice main function in there for us that we can run, and it'll carry out the main control flow and logic of the program using the other classes that are in place. And so we see our main function here. So I'm going to go ahead and run that, right click and say run as Java application, just to show you what it does. So this program requires input from the console. In this case, it's using a scanner, the scanner class. And so when you run this, you'll get the console tab popped open here in Eclipse. And the first thing we see is a prompt to enter in an image path. And so while you're working on this, I've provided you with a folder to put images in to play with, and I've also provided you with a single image. So over here at the top level of our of our project, we have the images folder and we have mentorcenter.jpg, which is an image. I'll just show it to you real quick here. And let's see, we're in images, and yeah, here it is. So it's just a picture of the Mentor Center. This is from our grand opening in October of 2015. And so we can apply some different filters to this image to see how our program is working. Okay, so the program is just waiting for me to enter in the name of an image file. And so it's telling me that it's relative to this location. This is the location of that images folder. So you can enter in other images, but you need to use relative path names. So if you wanted to enter in the name of an image that was in the JavaTrack folder but not in images, you would have to use, you know, the ... notation to specify to the program to go up one level. But here we can just work within the images folder directly and just enter in file names. So if I type in mentorcenter.jpg and hit enter, I get a filtered image. All right. So this is just applying the single filter that we have in our application so far. It's called blue filter. It's in the filters package. And we'll talk a little bit more in detail about what that's doing. But you can just see that it just applied a blue filter. It got rid of all of the non-blue color information within the file. And so we want to use some similar logic to create additional filters and then additionally give the user the option of choosing which filter gets applied to their image. So now that I have filtered this image, my program is still running. So we see a message that the image was successfully filtered. We also see a prompt that we can save the image if we like to the same directory. Now, let's see. So let me just go ahead and save this to mentorcenter-blue.jpg so I can keep my original file. Tells me that it indeed saved it, and it gives me the full path of where it saved it. Let's go see if it's there. And there it is on our file system. So there is the actual image on our file system. Great. Okay, so then we can close that out. And yeah, so you can keep that around if you want. I'm just going to go ahead and delete this for now. So that's how our program generally should work. So we're going to be adding functionality and extending it and making it a little bit more robust. I'm not going to talk about all of the to-dos and all of the tasks that you need to complete. Those are specified in the problem set walkthrough on the website for the course. But let's just look at a few things that are kind of more important here. So Javagram is our class that serves as the sort of control class for the program. It's the one that has the main function that's running here. So what is it actually doing? We saw the behavior in the console down here. What is this doing within the program? So one of the things that I have to do is kind of deal with files on the local file system. I had to read in an image here from this file that I specified, and Java needs to have a way to find that image on the file system. I only typed in the name mentorcenter.jpg and the rest of the logic to determine that it was in a specific folder on the file system is contained within this program. So up here we have just an array of strings here called base parts that just kind of builds up the pieces of the path on your file system. So in this case, when I say system.getProperty user.dir, that gets the project root folder for my Eclipse project. So that grabs the path all the way up to this part right here, all the way up to JavaTrack. So this is going to be different for you on your file system. You're going to definitely have a different username. You might have stored your code in a different location. If you're on a Windows machine, you're going to see something very different. You're going to see backslashes instead of forward slashes. You'll see a C:, at the front of it. So paths within a file system can look very different. Our program should be able to deal with that in a reasonable way. This is how we deal with it. We say that we know that there's an images folder in our project, right? That came down with the starter code. So let's just figure out where we are now. No matter where we are, let's figure out where that is. And then we'll go one level deeper within the image folder, and we'll use that as kind of our base folder for working with images. So again, you can change. You don't have to always use images that were within this folder, but if you're going to use images that are somewhere else, you need to give it a relative path name. And that's because Java will build up the full file path, something that looks more like this, right? This is a full path to a specific file. It's going to build that up using the information that's stored in the top here. So base parts is an array that just gets the pieces of this path and gets ready to put them together. It also uses something called file.separator. Separator is a static member on the file class, and that's going to be specific to your operating system. So that separator is the / or the \, depending on which operating system you are using for your work. Let's see, we have a scanner. So you want to use this scanner throughout your program. The scanner, recall, will allow you to read in information from the command line. We use a scanner instance that pulls information from system.in. That's just the console down here. That was where I was typing earlier. And then let's see, we have a do while loop. This is where we're getting the information for the file that we want to work with, the file that we want to filter. And it's in a do while loop because there's a little bit of validation. So here I have a picture reference. Picture is a class that's in your project. It's right here. I encourage you to look at it. This is something that's just provided for you. It's representing conceptually an image, a picture image on both on the file system and within your program. And you can use JPEG, GIF, or PNG images with this picture class. We're just going to use JPEG for the purposes of this walkthrough, but you can use, if you want to filter other images, you can use those other types as well. So you'll be calling various methods on the picture class, on picture objects throughout your program. I encourage you to don't be afraid of diving into this source code and looking at it, at least to figure out what it's supposed to be doing. All the methods here are commented. You can see how you're supposed to call methods, etc. So we have a picture reference here, and what we want to do is when we get the file name from the user, we want to make sure that that corresponds to an actual image. So within this do while loop, I prompts the user to type in the name of an image file. I then build up the actual image path to that file using all these different pieces that we've gathered before. And then I try to open it. So this is where the opening comes in. When I go into the picture class and try to create a new picture based on that image path, if I can't open that file, if that name that I typed in doesn't correspond to a real file on the disk, there's going to be an exception. It's going to be a runtime exception. So here I'm catching the runtime exception just so I can say not let my program die, but that I can print out a message and then reprompt the user to enter in something that actually does exist. I can say could not open the image, tell them what I tried to open, and then while the picture is still equal to null, I can go up and prompt them again. So that's just a bit of validation, and you're going to add some similar logic to validate other types of input within your program. Okay, so far our program only has one image filter, and that turns everything blue basically. So there's a get filter method here, which can be used to fetch a filter. You're going to change the way this method works. You're actually going to change its method signature. It's defined down at the bottom of our file. Notice that it's a static. It's a static method, so we don't need to have a Javagram object to actually call this method. We can just call it statically. It's also private. It should really only be used within the class that we're in. So right now, it just creates a single blue filter object and returns it. What you want to do is you want to be able to pass in an argument, an integer that corresponds to one of many filters, decide which filter the user wants based on that integer, and then return that integer. So again, more information about exactly how that's going to work in the problem set specification on the website. So up here, so we have our image now. We've gotten a filter, and the filter has a method on it called process. So if we go over to blue filter, we can see that it only has one method, and it's called process. And really what it does is it just takes in a picture object that we call original. It creates a new picture object called processed, and then it loops through the image and transforms the pixels and puts the new pixels into the processed picture. So basically the way you should think about this is that these two nested for loops are going to go from left to right and top to bottom within the image. So notice that there's these variables I and j. I corresponds to the left to right location. J corresponds to the top to bottom location. So you can think of I as your column and j as your row. And so we're just going to loop through every single pixel in the original image and then pull the color data out of that pixel. So color here is a class that represents an RGB color. And so RGB is something that, if you're not familiar with, is pretty easy to pick up the concepts of. And we link to a great video on learning about RGB in the problem set specification. So this color object represents an RGB color. So we can get a specific pixel color from the original image by using this method right here. So saying original.get and then giving it the pixel coordinates of the pixel that we want. So each time through the loop, this line will pick out one pixel as an RGB pixel. And then you can get at the specific colors within that pixel by calling the getRed, getGreen, and getBlue methods on that pixel, on that color. And then to set them, you can, in the new image, you just say process.set. This will set a specific color on a specific pixel in the new image. So remember that original is the image we're reading from, processed is the image we're writing to. So this will set the ijth pixel to be the given color. And notice here that we've turned our image blue by simply setting the red and green pixels to be 0. The blue pixel, just to kind of make this reasonable, we've taken the average of all three colors, just so we have a similar level of darkness, basically, as is present in the original image. And so that's just the average value of the red and green and blue pixels. Notice that that's still going to be a number between 0 and 255, which are the valid colors for RGB, and that just sets the blue pixel to be that color, or the blue portion of that pixel to be that value. And then process then returns the processed image, and that's where we are over here. So we have a processed image object in place in our code here. We call processed.show to display that image. That's what opens up the window that we saw. We put down just a little status message, and then we do the work of trying to save the image. So there's some work you're going to do here to make this a little bit more robust. So for instance, a user should be asked to confirm if they want to save over the original image, which is kind of a dangerous thing. People might accidentally overwrite their original file. So you're going to add logic to double check that they actually want to do that, to confirm that if the user types in, if the user starts to try to save their processed file to the location of the original file, that we make sure that that's really what they want to do. And then at the bottom here, at the bottom of our main method, we just close our input stream to make sure we're not leaking memory. And so that's the basic concepts here. You're going to be adding filters. So you're going to be adding a bunch of logic to deal with multiple filters. Right now, there's only one filter. Part of that is going to be creating an interface for filters so that at some point you will be rewriting this line of code so that you'll have an interface named filter, and getFilter returns an instance of that interface rather than something like blueFilter, right? So you'll be doing that part of the project. As you create filters, you should put them in the Javagram.filters package here. To do that, to create classes or interfaces within a package, you can just right-click and say New, and then choose whatever you like, and it will automatically put it within that package for you. So I'm not going to go ahead and do that. But as you're doing that, as you're creating your stuff, use the organization of packages here to put things in the proper place. The only classes and interfaces you're going to be creating are going to be filters, so you can add all of those here. You'll be doing a fair amount of programming within the Javagram class up here, but you won't need to add any code to the top level Javagram package. All right, so there's a lot to do. Again, I didn't go through in detail all of the tasks that you need to complete, but you should make sure to read the detailed problem set specification on the course website, and talk to your instructor and or TFs or fellow students if you get stuck or have any questions. Good luck.